Thank you for attending this talk. My name is Ben, and the topic of this talk is remote split-second phantom attacks on AI models of semi and full autonomous cars. A few words about this talk. This talk is based on 3 papers that were published in the last 3 years. They are online. You can find them, and they were published on CCS 2020 and in AutoSec workshop last year. They were co-authored by a group of scientists from Ben-Gurion University, and let's start. So with that in mind, let's discuss about perception of computerized driver intelligence. Virtual perception is the ability of computers to interpret the surrounding physical environment using algorithms that obtain data from various sensors. And virtual perception of semi and full autonomous cars usually consists of algorithms and hardware structured in layers. And on the bottom, we have the sensors. On top of it, we have the sensor refinement layer. On top of it, we have the object refinement layer. And on top of it, we have the situation refinement layer. And the 2 upper layers consist of AI models. And the focus of this talk is on basically the third layer, which is the object refinement layers and object detectors. Now, for those of you who are not familiar with object detectors are algorithms which are used to identify the location of instances of objects of a certain class. And they receive frames as input, and they output a set of bounding boxes with the classifications of the associated objects. And as you can see, there's an example for a pedestrian detector, a car detector, and a road sign detector. So let's try to review how actually we create object detectors. So object detectors are the output of a long iterative training process where we aim to optimize the accuracy or some other condition of deep neural network on a training data set. And we actually stop this iterative training process when the condition converges. And previous studies have already discussed the disadvantages of using a training process to create AI models. They discussed the high level of computing capabilities. They discussed the high energy consumption. They also discussed the high cost and the long training time. But it seems that the training process is effective at transferring the needed driver's experience required to steer a car, because as you can see, the statistics shows that AI models function better than human drivers in real life. However, we are actually interested in a different type of questions. What are the limitations of the training process in terms of transferring a driver's experience to the model? And can these limitations be exploited by attackers? So with that in mind, this is a nice experiment that we did that actually is the basis for the entire research. We actually took a projector and projected the picture of Mr. Elon Musk on the road and also a road sign on a tree, as you can see. And here is a question for the audience. Do you consider the projected character a real person and the projected traffic sign a real speed limit? And hopefully, the answer is no, but here are 2 interesting facts. Tesla Model X considers the projected person a real obstacle, a real pedestrian, while Mobileye 630 Pro considers the projected road sign a real speed limit. And this is highly interesting because this version of Tesla Model X, that with the hardware 2.5, actually equipped with sensors that intended to detect death. Okay, it contains radar and a set of ultrasonic sensors, and this is a deathless projected person or character that is projected in front of this Tesla Model X. Okay, and I think that you will agree with me that there is a gap between what an AI model thinks it is and what there actually is. As you can see, AI detects visual phantoms, some optical illusions that would have been ignored by a human driver. And moreover, as you can understand, the training process is limited at transferring some of the characteristics and the experience required to distinguish between fake and real objects. Now let's discuss about split-second phantom attacks. Split-second phantom attacks are attacks against advanced driver assistance systems that exploit the inability of AI models to distinguish between fake and real objects. And attackers can apply split-second phantom attacks in two primary threat models. In the first threat model, attacker remotely hacks an internet-connected digital billboard and use it to present a phantom. And in the second threat model, the attacker flies a drone equipped with a portable projector and projects the phantom on a road, on a building, on some other nearby structure. Now, in both cases, the phantom is perceived as a real object by a nearby advanced driver assistance system and triggers an automatic unexpected reaction. Okay, so this is an additional experiment that we did where we show how attackers can find the minimal period of time required to attack an advanced driver assistance system using basically a simple experiment that anyone can apply. And as you can see, we took a television and we projected phantoms on the television in different periods of time. And we actually tried to measure the success rate of the attack as a function of the period of time needed to project this type of phantoms. Now, by using this knowledge, attackers can actually take it one step further and to try to compromise a digital advertisement by first finding dead areas in the digital advertisement, okay, in order to make the attack somehow less detected in the case of a semi-autonomous car with a driver inside, and they can spot dead areas and try to compromise these dead areas of the digital advertisement. And this is an example for the basically the output of the algorithm that was suggested in the previous presentation. As you can see, we basically compromised 500 milliseconds of this nice McDonald's advertisement with a stop sign. And the next thing that we did is we took this advertisement and presented it on a digital billboard while we engaged Tesla's autopilot. And as you're about to see Tesla's autopilot, and you can see the dashboard of Tesla's autopilot on the left side, detects these 500 milliseconds as a real stop sign. And as a result, it triggers the car to stop in the middle of the road. Now let's see it one more time. Okay, as you can see right now, the stop sign is being presented, and Tesla again immediately stops the car in the middle of the road. Okay, now there's another way to apply the attack, which is by using a projector. Now, as you can see, in this case, we mounted the projector to a drone, and we were flying the drone to inside our university and projected a speed limit, which is way beyond the speed limit that is allowed to drive in our university. And again, this was perceived by Mobileye 630 Pro as a real speed limit, despite the fact that, as you can understand, this is a split-second projection. Now, moreover, this can be applied by attackers using a projector from the side of the road. As you can see, we projected a depthless picture on the road, which was perceived as a real obstacle by Tesla. And as a result, Tesla reduced the speed of automatically from 18 miles per hour to 14 miles per hour. And again, I just want to mention Tesla is equipped with the needed sensors to detect that this is a visual illusion, which is depthless and should have been ignored by this machine, by Tesla. Now, finally, we also suggested a countermeasure that we named Ghostbusters. Ghostbusters is a software module. It is designed for basically validate the output of an object detector. It can be used to determine whether a detected object is phantom or fake or real. And the architecture of this countermeasure consists of 5 convnets. Four convnets, each of which was trained to detect specific characteristics related to one of which, for example, was trained to detect characteristics related to context. The second convnet was trained to detect characteristics related to surface, and the other 2 were trained to detect characteristics related to light and depth. And the 5th convnet was used on top of the 4 convnets and as an ensemble layer in order to detect phantoms based on the embeddings of the other 4 convnets. Now, as you can see, the area under curve of the combined model, which basically used the embeddings of the 4 models together, is better than any subset of the convnets, and also by each of them as a single model alone. So finally, we also used Ghostbuster as a second layer of validation, and we applied to basically mitigate attacks against state-of-the-art object detectors. And as you can see, we were able, or by doing so, we were able to reduce the attack success rate from 99% to less than 1% when the countermeasure, when Ghostbuster was applied for validation. And basically, this is it. I would like to thank you for attending this talk, and this is a good time for us to take some questions from the audience. And while I've also mentioned who's the character, so as you can understand, this is a picture of Mr. Elon Musk, and as you can understand, again, Tesla detects its own boss, even as a phantom. This is it.
Thank you, Ben. That was wonderful. We do have a few questions before I let you go, unfortunately, or fortunately. One question: can we mitigate the attack with the use of ultrasonic sensors such as radar or lidar? How does that work, please?
Okay, so for those of you who are familiar with the Tesla is equipped with this type of sensors, with ultrasonic sensors and radar. And I want to say that basically mitigating the attack is not a technological, I would say, challenge, because you can fuse sensors, you can fuse the object detector, which obtains data from the video camera, with the object detector that obtains data from the radar, and detect there is some difference or there is a disagreement between them. And by doing so, you can, if you want, detect the phantom. However, for the case of phantoms, phantoms are in a way, so as I mentioned, Tesla actually equipped with this type of sensors, but phantoms exploit the fact that the car industry opts false negative that may, for example, lead for ignoring real pedestrians over false positive, which may lead to react to a phantom pedestrian. So in this case, even if you will be able to detect that there is some disagreement between the video camera and the radar, the main question is, what do you opt to do? What do you want to do? Okay, do you want to opt the approach that says, let's go for safety, or you want to opt the approach that says, let's follow security? And basically, you have a trade-off in this case between safety and security. And this is one example for, this is one fact that phantoms can exploit, even if you have the needed sensors to detect the fact that there are illusions.
Okay, thank you. We have a question come in from one of our viewers. Does solving the attached phantom hinder some of the ability to detect real objects?
What is the question? To solve what?
Sorry, yeah, I'll repeat the question. Does solving the attack phantom hinder some of the ability to detect real objects?
Does solving the attack, again, can you please repeat it?
Does solving the attack phantom hinder some of the ability to detect, does it stop some of the ability to detect real objects?
Okay, so again, there's a trade-off. Basically, you can resolve and detect phantoms with either, for example, using additional sensors, by using data from additional sensors. But again, it comes with a risk, okay? And the risk is that in some cases, if you will consider something and you will decide that you may consider it as a phantom, there's a risk that you will also miss a pedestrian that for some reason wasn't detected by a sensor, okay? And by doing so, this may lead to an accident. So again, it comes with a trade-off on what you want to opt, whether it's safety or security. And maybe it is better to consider phantoms as real objects instead of the opposite, and maybe somehow risking, the lives of three pedestrians that for some reason that are related to sensors, maybe to weather conditions, weren't detected by the additional sensors. Okay, I hope this summarizes this.
Okay, thank you, Ben. We have another question here. How did you determine the minimal period needed for the split-second projection or the presentation in order to attack the car?
Okay, so we basically showed it in the talk where we showed how basically you can take a television and use some videos with changing their periods where they present phantoms to the advanced driver assistance system, and by testing the way that the advanced driver assistance system reacts to this period. And when it is being detected, and the first time it is being detected, you started with the minimal amount of time, and you extending this time, the period of projection or the period of presentation in each iteration until you first find the minimum amount of time it's required to project or to present a phantom to basically the AI of advanced driver assistance system.
Okay, thank you. One more question to come in, which is that the technology could identify things that have been shown via a drone or a projector of any sort. But what about people that literally print out stop signs on pieces of paper? Would the car be able to identify printed versus?
Okay, good question. Basically, these are good type of attacks, but think about it in a way. The main thing with the split second or the remote split second phantom attacks is that attackers can apply them remotely. Now, this type of attacks that you just suggested require the attackers to approach the attack scene. Now, in terms of attacking, in terms of wanting to remain anonymous, this is not a desired feature for an attack, okay? And as a result, attackers will probably prefer or opt to apply a remote attack, such as split-second phantom attacks, instead of applying an attack that requires them to approach the attack scene.
Okay, thank you. Now, autonomous vehicles have been kind of promised on our streets by the Elon Musks of the world every year for the last 5 or 6 years. At what point do we see this to be a very real problem that affects you and me, and not just the small 1% of cars that are on the road at the moment? How far are we from this being a real consideration?
Okay, I cannot answer it because, as you can understand, attackers can apply this type of attacks. The main question that needs to be asked instead is what is the motivation for attackers to apply this attack? The main thing with remote attacks, this is basically a sensor-based attack, okay? But it's the first time that we were able to show a remote attack against sensor, because usually you need to come to the attack scene to implement some, equipment in order to attack a sensor. So think about it this way. Maybe sometimes in the cyber warfare, let's say for now, in the case of Ukraine and Russia, okay, maybe one of these countries will want to attack another country, like creating a cyber warfare or something, by projecting or by hacking a digital billboard of the rival country, and then use it to project basically a phantom, like a stop sign that will cause Tesla, for example, to stop in the middle of the road. So it's mainly a question of motivation rather than anything else, because this attack, as you can see, Tesla responds to this type of attack, and they are hard to mitigate. It's not easy to mitigate them, even if you will use some database and you will incorporate some GPS measurements, because you can never distinguish between a temporal stop sign and permanent road sign, and you need to take both cases into account. So you will have, at the end of the day, take the video as the imagery data as something that you need to consider it reliable in order to be able to detect some temporal road signs. So again, it's a question of motivation, not a question of basically something else, in my opinion.
Okay, now you mentioned motivation and the reasons why people are doing this. I spoke to someone once that said that autonomous vehicles won't operate on the road completely until, or completely and successfully until every single vehicle is replaced and is autonomous, and that autonomous vehicles and human drivers can't quite coexist together, together. What are your thoughts on that? And does this technology have anything to do with that
okay,
problem?
I will say two things. I can support some of the claims that were mentioned by your colleague. I will claim something else. I think that we need for additional, basically help from the infrastructure. Okay, whether it's cars, whether it's the road signs, whether it's the signals and the lights. We need the needed protocols in order to help the autonomous cars to take part, to drive between human drivers. But having that in mind, you cannot ignore the fact that there are pilots where you can see Waymo in the US and some additional companies like Zoox, for example, that provide or able to drive in a specific, I would say, area after they memorize this area without the use of a driver. So it's true that completely autonomous vehicles, somehow it will be easier for them to drive among other autonomous vehicles. But as you can see, we are currently in a situation where autonomous vehicles can, I would say, drive in specific areas that were memorized by them. And you can see this basically in the US in the pilots that we have there.